Let's have a look on the following questions. Question 1. Diagram 1 shows the relations between set x and set y in the graph form. When you have a graph that shows you the relations between both sets, always remember the x-axis, the horizontal axis, refer to the domain, and the y or vertical axis refer to the codomain. You can always transform a graph to an arrow diagram, So this is what you have, an arrow diagram. On the left will be your domain. On the right will be your codomains. Domains will be mixed up from the objects. Codomain will be formed by the images. So when you have an arrow diagram, it's very clear how you can find the objects for Q. So you have a look, the objects of Q would be 1 and also 3. For codomains of the relations, for domain and codomains, always remember to put a bracket. Codomain basically includes the images that has been mapped into the objects, the image that has been connected to the object. So it's not PQRS, but PQS only, because R is not connected to any object. So you write PQS. Alright? Question number 2. Given the function fx and gx, find f7. So simple, you just have to put 7 into x. So 7 plus 3, you have 10. B, gf7, a composite functions equals to 19. For a composite function, you have to remember it always starts from the right hand side, not the left hand side. So you deal with f7. Do you know the answer for f7? You do, equals to 10. So you can replace f7 with 10. G10 equals to 19. You can substitute x into the equation of gx. So 10k minus 1 equals to 19. The value of k. Okay? Question 3. It's given that alpha and beta are the roots of the following equations. Alpha equals to 4 beta, where p is a constant. Find the value of p. This is the question for SOR and POR. When you have alpha and beta at the roots, you know this is about SOR and also POR. SOR is the sum of roots. So you have alpha plus beta. Since you know alpha equals to 4 beta, so you can replace alpha with 4 beta. So you know that the SOR equals to 5 beta. POR is the product of roots. So you don't use alpha beta, but you use 4 beta and beta. 4 beta squared, POR. Once you have these informations, you can compare this with the formats by using SOR and POR. Remember the format to form a quadratic equation. This is the one, right? Right. And if we were to compare this with, can we compare it straight away? No, right? We have to expand it first. Group it. Okay, we compare and see. Is it very similar? No, right? What else do we need to do? Have a look. The coefficient here is 1. The coefficient here is 2. You need to make sure it's the same. So this whole thing divided by 2, x squared right? 0, still 0. You compare. SOR equals to negative 5 over 2. Do we know SOR? We do, right? 5 beta. We put in. Negative 1 over 2. For P, we are not done. Huh? We compare POR. Okay, POR just now what we have is 4 beta square. Okay, and since we know beta, we can put in 1 over 4, 1. Right? Done. Question number 4. Question number 4. Diagram 4 shows the shaded region that satisfies a quadratic inequality. The shaded region over here, as you can see, is below the x-axis, so it should be less than 0. Am I right? If you describe this into a function, you can call it as fx or gx, up to you. But what you know is this quadratic function must be less than 0 since it's below it, or it could be less than equal along the line. So fx less than equal 0. How do you describe these quadratic functions? We have the roots. So 2 methods to solve it out. You can build the quadratic function first before you do the inequality. The first method is SOR POR. Right? You can form the quadratic functions. Make it nicer. This is your quadratic equations. Make it a quadratic. Make it a quadratic inequality. So we know that this quadratic function is less than equal 0. This is your final answer. Or since you have the roots, you can also do it this way. Right, since both of these equals to 0, you can group them together. Right, you see, you have the same answer. You form the quadratic inequalities. You know that is less than equal 0, so this is your final answer. Okay? Alright. Question 5. Diagram 5 shows the graph of quadratic functions. You have to know this is the completing the square form. So this form helps you to identify the coordinates of the turning point. If you still remember the formats. To make it 0, x value to make it 0, that is the x value for the turning point, and this is the y value of the turning point. So you can compare and see. To make it 0, x has to be 3. So the x value of the coordinate 3. This is your y. So 2p minus 1. And when you look at the diagram, you do know about the turning point. It is over here. You can compare with it. So m equals to 3. 2p minus 1 equals to negative 7. A little bit of calculations. So p equals to negative 3. The value of n over here. This is the y-intercept. So x equals to 0. We can build the equation again since we know the value for p. (2p minus 1). 2p minus 1 is negative 7. So you can just put negative 7. When x equals to 0, y-intercept n equals to y. You have n equals to 2, right? 9, right? N equals to 2. Okay. Question number 6. Solving the equation. Now this is about indices. When you are handling with indices, one important rule is you can always change them to the same base. Okay? Change them to the same base. So we know that 3 squared equals to 9, 3 cubed equals to 27. So we can change 9 and 27 to the base of 3. Square root, move the other side, you have a square. 9 minus 3x. 1 square is still 1. Okay, this is the part. Remember, you can write it in this way. They have the same base. You can ignore it. Look at the power. X equals to negative 9. Question 7. Find the value of x. The log is with a different base, with 9 and 3. Same thing. The first step, we change them to the same base. We're changing 9 to 3. This is the formula that I use. And 9, I can change it to 3 square. And when I have 3 square, the power, I can put it in front. When I put it in front, it will be and when you have log 3, it will be equals to 1. 1 times 2, you have 2. So this is what you have. Move it. And then now you can make it a power. They have the same base. You can ignore it. Look at this part. X equals to 4. Number 8. Diagram 8 shows a straight line. So you have equations parallel with another line. So when you have two lines parallel to each other, you know that this is about M1 equals to M2. M1, M2, and they are the same, parallel lines. You can compare them into the gradient form. So M1 here is B plus 3. This is M2. To find the value of B. Alright. Question 9. The diagram shows a graph with, okay, you have another coordinates is a locus R. The condition is always equal distance from P and Q. To do that, if you want to have a coordinates that's always equal distance from P and Q, one of the possible coordinates would be the midpoint of PQ. Do you agree? If I have the midpoint of PQ, I have the same distance for RP and PQ. Am I right? This could be the possible case. It could be not on the line of PQ. It might be here. The R coordinates, you still have equal distance for RP and also RQ. Make sense? Or it could be here, or it could be here. Anyways, you will still have equal distance for RP and also PQ. So when you visualize this, all the possible result of R, eventually it will form a straight line. Am I right? And this straight line, if you can see it, it is the perpendicular bisector for the line PQ. Perpendicular bisector. So you are looking for the locus of R always equals distance from P and Q, basically the perpendicular bisector for PQ. Two methods to sort this out. The first method is, first we figure out the coordinates of P and Q first. Okay, Q is x-intercept y equals to 0. So when you put in y equals to 0, P, y-intercept x equals to 0. You have the coordinates for P and Q. Important, So the first method is, I put here, this is R, I call it xy. Since RP equals to PQ, this is the case. You can use the, or RP equals to RQ, sorry. RP equals to RQ. We can use the distance formula. RP. RQ both with a square root, you can ignore it, or you can square on both sides. Cut off, cut off, cut off, cut off. You don't have x squared and y squared because it's a straight line. So you have y and x. This is the equation of the locus, 12y plus 8x plus 20 in general form. This is one of the methods. You use the distance formula. If you don't use the distance formula, what else can you do? You can find the gradient for PQ and then find the gradient for the perpendicular lines. And you form the midpoints. Yeah, it's a bit long. You can do that as well, no problem. Okay, question number 10. Question 10. A set of data x consists of 5 possible numbers. You have the mean, sum of x squared, and also the standard deviations. Expressed in terms of k. Okay, so you can use the standard deviation formula to connect all the info that you have. Standard deviations formula. The mean, the number, total frequency, no. Sum of x squared. Okay, this is the formula for standard deviations. You just have to put in the info that you know of. 2k. 1, 2, 5. 5 number. And the mean is, okay, square root. Square root with a square. Nothing, eliminate each other. H in terms of k, okay. Oh, no. H in terms of k, H equals to 25 minus 4k squared. Done? 11. A distribution of score. Obtained by a group of participants in a quiz. The score, cumulative frequency. Okay, then you must have a frequency. Cumulative frequency 3, 10 minus 3, 7, 25 minus 10, 15, 10 and 5. When you add up, you should have 40. 3 plus 7, 10, 20, 40, right? So the number of participants, 40. Find the mean score. Middle value. Oh, not 25. I should look at the frequency, not the total frequency. Be careful. You look at the frequency, not the cumulative frequency. 10, 20, 40. Okay, and divided by 40. 8.525. The mean score. Question 12. Diagram 12 shows a sector OPQ with a center given pi. Pi is not even needed. Find the area of sector OPQ. So you have the length of arc. S equals to r theta. Theta is in radian. 6.8. 6 theta. So theta equals to 17/15 radian. Find the area of sector OPQ. Another formula. R square theta (20.4) cm square. Okay, you don't need 3.142. I don't know why is it there. The gradient functions dy dx. P is a constant, the turning point 31. Find the value of P. Okay, when you have the gradient functions, you know, right? The gradient equals to 0 for the turning point. So gradient equals to 0 when x equals to, you have the turning point, right? The x value, x equals to 3. I repeat one more time. When you have the turning point, maximum or minimum, whether it is a maximum or minimum point, the gradient for the turning point, it is always equal to 0, a flat line, horizontal line. So I put 0 for the gradient, and since I know the x value for this turning point, so when x equals to 3, dy dx equals to 0. So I put in 3. The equation of the curve. Now we know the value of P. We can change it to 2x minus 6. dy dx 2x minus 6. You have the equation of the curve. So you must have the subject, the y as the subject of the equation. So how do you have y? The reverse process, integrations. So you integrate 2x minus 6. You have x squared minus 6x plus c. Okay? So this is y equals to 6 squared minus 6x plus c. Figure out the value of c. How do you figure out? You have the turning point, x, y. Put in. You have the value of c, you write again. Equation of the curve. 14 is given that the first term and the last term, the sum of the term, find the number of term and common difference. Okay, 3480. Everything lah. So I can put 3480 equals to n over 2. I don't know how many of them, but I can use the formula of a plus l. Since I know a, the first term and the last term, I can put in. Then I can figure out the number of terms. 40. Number of term is 40. I have this information, then I can use another formula. Not A and L, but 2A plus N minus 1D. I use this one so that I can find the D. Oh, sorry. A, 9, 40, 40. D equals to 4. Okay. 15. 3 consecutive term. Consecutive for AP. So they share the same common difference. Eq minus share the same common difference. Okay, this is what we have. Y equals to -1, right? Okay. We have to find the common difference. D equals to 2. 16. We have a look. Given that 0.0363636 is a recurring decimal number, when you have recurring decimal number, you know S infinite equals to A over 1 minus R. So to give you a better understanding, equals to do you agree? The two numbers will be repeated, will be 3 and 6. And when you do that, the sum of it, basically this is the sum of GP and to infinite. So you need to find the R in order to use the formula. You can use this one, divide by this, right? T2 divided by T1. This is your R. You put in the A, the R. You should have the answer in fractions. Two over 55. Okay. 17. Diagram 17 shows a part of a graph log 10y against log 10x. the variable is related by the equation of y equals to bx to the power of n. Find the values of b and n. You have to know this is the non-linear form. The graph changed the non-linear to the linear form. So it's always changing from a non-linear to a linear, or changing to a linear from a form linear. It's easier to change a non-linear to a linear form. So I refer to the y-axis. So I know this is the capital Y. I know this is the capital X. Y equals to mx plus c. So in order to have log 10, I will have log 10 of both sides, changing this non-linear form to a linear form equation. So I have log 10 on both sides, and since this is multiplying, so I have 2 more log with additions. Change places. This power, you can put it in front. Do you recognize y equals to mx plus c? So this is just to show you that the gradient here is n, and the y-intercept is log 10b. When you know this, you can find the gradient and the y-intercept from the graph. How do you find the gradient? You must have at least 2 coordinates. So the gradient here will be y1 minus y2, 6 minus 0, you have 2, so 2 equals to n, that is the value for n. Do you know the y-intercept? This is your y-intercept. You can change to indices form. 10 to the power of 3 equals to b. b equals to thousands. Okay? Changing a non-linear to a linear form. Or you can change a linear form to a non-linear form. You compare and see. But it's always easier to change a non-linear form to a linear form when you have the graph. Number 18. This is given. Okay, the difference between what is given and what is being asked is the lower boundary and the upper boundary. It's reverse, right? Okay, so you can change this to, if you want to swap the boundary, you put a negative sign, then you have it swapped. And since we know this value, we replace this with 3, negative 3. Okay. Subtractions. You can separate into 2 parts. 7 minus 7x, and here you know this one is 3. $18 is your answer. Okay? Question 19, you have three vectors OA, OB, and OP. For 19A, you need to find the magnitude of OP. So you need to look at the diagram. Start from O, end with P using I and J. To travel from O to P, one step to the left, so negative 1i. 5 steps to the top, plus 5j. This is the vector for OP lah. But what we want is the magnitude. So you need to continue from here. The distance, the magnitude. What do we have here? 5.099 units. Magnitude of OP. B, vector of OB in terms of A and B. So we have to look at A and B first. Okay, A is like this, the directions. B is like this, the directions. So you need to think of how do you start at O, end with P. O travel to P using A and B only. So maybe you just have to try lah. OA. And then another OA. Am I right? And then B. Then you have O to P. Okay? So this is A. This is also A. This is B. To travel from O to P in terms of A and B, AA. So 2A plus B. This is your answer for OP in terms of A and B. Okay. Question 20. Let me lap off. Okay. It's given that vector R and X is given. Express vector R plus X. So you just have to add up together in terms of K. So add up. So 4 plus K, it is still 4 plus K. 6 plus negative 9, negative 3. This is the answer for A. Quite simple, this paper. It's given that magnitude of R plus X. So the magnitude are square root equals to 10. Then you have to find the value of K, the positive one. Hundreds. (16 minus 9 minus hundreds). Oh, sorry. 16 plus 9 minus hundreds. Okay, I tried already just now. The answer is going to be in decimal point. So you have to use this formula. Remember your ABC, your B is 8, A is 1, C is negative 75. Okay, let's see what we have. $5.539, the first answer. negative 13.54. Since oh, this is k, not x. Since we can only have the positive answer, so we write again. So k should be 5.539. Only one answer, positive 1. 21. Solve the equation sec square theta. Okay, you look at sec square, you can either turn into 1 over cos square theta, or there's another formula for sec square theta, right? Equals to 1 plus tan square theta. So which one would you replace with? Definitely you will go for different, right? Because you have another tan theta here. So probably is related. So you can change sec square theta to 1 plus tan square theta. Okay. Then try to put them everything on the left hand side. If you cannot see it, let me show you. You can let tan theta equals to x. And when you do that, you have x squared plus x minus 2 equals to 0. Then you know how to solve, right? Then you can say that tan theta equals to negative 2 or 1. Okay, so break into two parts. The range 0 to 360. If tan theta is negative 2, or you have to remember the quadrant as well. Or science teacher crazy. Tan theta to be negative. In order to be negative for tan, it is the second one and the fourth one. Second quadrant and fourth quadrant. You have to remember reference angle. Okay, shift tan to reference angle is 63 point. I write the reference angle first. I put it x. The reference angle is 63.43 degree. Okay. Quadrant 2. 180 minus 116.57. Another one, quadrant 4. Okay, so theta either 116 or 296. Quadrant 2 and quadrant 4. Okay, another one, tan theta equals to 1, positive. So quadrant 1 and quadrant 3. This one, you can find the theta straight away. Quadrant 1, the reference angle, 45. Another one, quadrant 3, so 180 plus 45, 225. So you should have 4 answers for theta. (22) Diagram 2 shows each letter word. Find the number of different ways arrange all the letters in a row. You have how many cuts? You have 8 cuts. So you have 8 cards, you arrange it. Okay, 8p8 lah. You have 8 options, right? You have 8 cards and you're going to arrange all 8 cards. So 8p8, 8 factorial. How many ways? Oh, a lot of ways. Okay. B. 4 letters to be chosen from the words. Chosen only, you don't have to arrange it, so it should be C. Choosing a 4 letter consists of 3 consonants. How many consonants we have? 1, 2, 3, 4, A, E, I. 5, A, E, I. 1, 2, 3, 4, 5. 5, we have 5 consonants. So there are 5 consonants and we're going to pick 3 of it. And another one is we have how many vowels? 1, 2, 3. 3 vowels and we're going to pick 1 of it. 5C3, 3C1. The way of choosing it. Okay. 23. Oh, this is probability. This is probability. Let me have a look. Two-side society of a school has 8 male members and 12 female members. 2 members are to be chosen at random. Both members are male. Okay, straightforward. So for the first time, the chances of getting a male member, you have 8 male members out of 20. 8 over 20. For the second time, now you don't have 8 males anymore because 1 has been selected. So now you have 7. And total, not 20, but 19 only. Probability lah. 14 over 95. Okay. They are of different genders. So it could be male, female, or female, male. 2 cases. Okay, male, female. Male. 8 over 20. Female, how many? 12. Now 19 only. Female first. 12 over 20. Male, 8 over 19. Let's see what do we have. 48 over 95. Okay, final answer. 24. An unbiased coin is tossed for 200 times. Getting a hit is defined as success. Okay, find the variance of the standard deviations. Okay, so the sum is MP. So N is 200. P is the success rate of getting a hit, is of course 1 over 2. So the mean is 100. Okay, standard deviation variance. Figure out variance first. Variance equals to NPQ. N is 200. Oh, you don't need mean actually. Multiply with the success rates and the failure rates. So 1 over 2. So the variance should be 50 and the standard deviation square root of 50. .071. Okay, you don't need to find this actually. You don't need to find the mean. Just the variance and the standard deviations. Alright? 25. X is a random variable, normal distributions with a mean of 4.2 and the variance of 1.69. meaning the standard deviation is 1.3. Find the z-score. Okay, so you have to change the x value to z-score, if you still remember the formula. Right, so x is 5.7, the mean is 4.2, the mu, and 1.3 for standard deviations. Changing x to z, z is a standard score that can help you to read the probability from the table. 1.154. Okay, you need to find the probability between 4.2 and 5.7. That is between x. You need to change the x to z first. Okay, so x, that is basically, let me draw it to give you a better understanding. This is the one, right? 4.2 is basically the mean. Am I right? So between 4.2, I change this to a z value. This will be 0 in the middle. This will be 0. Between 0 and also 1.154, we are looking for the probability between 0 and 1.154. Because we know that when we read the table, it's going to this direction, right? So between, maybe, let me put here. So maybe this is 1.154. We need to find the shaded region here. Maybe you cannot see it. We need to find the shaded region here. Then how? From the table itself, what you know is you can find these parts. Okay, the whole part, the yellow color part. The whole part, the yellow color part is half of it, so 0.5. So you can use 0.5 minus the purple color part, the pink color part. The pink color part is basically the chances of z more than 1.154 going to the right directions, and you can refer it to the table 1.154. Okay, I have found it just now. 1.154. Am I right? So 0.1251 minus 8. You should have 0.1243. This is how you do. 0.3757 should be the answer. Okay, thank you.